You have the evens through 22. So here are the answers. If there are any that you're not sure what happened. Now, number 2 is perfect squares involved all around, except it's not the difference of perfect squares. It was addition. So there's nothing that they share. 10 seemed to trip some people up. All you're doing is removing the greatest common factor. It does not go into foiling. You're really only going to create foiling when you have difference of perfect squares, trinomials, or when you have a quadratic like 12, and then you've broken them down into the greatest common factors and then the items left behind. So remember to always, always, always look for the greatest common factor first.
Wait, can you mark 12?
12. No. All right, so it's 4. We're going to have 4 little clumpies. We're going to divide it in half. And then we're going to look for the greatest common factor for the first set. Oh, right there. So what would they share?
A 5.
They share a 5, and what else?
And m squared.
There we go. 5m squared. And when you remove 5m squared, what are you left with? Just in the first part.
3m.
You have a 3m, and then minus what?
-2.
Minus 2. All right. The whole purpose then next is when we remove the greatest common factor from the second set of plumpies, you want to have 3m minus 2 left behind. So because it's a plus 14, we're going to remove a negative. So figure out what the greatest common factor would be.
7.
And that would be 7, but we're going to say minus 7.
-7.
So negative 7. And then that gives us 3m minus 2. So it worked. We have the left behinds are identical. So you take the greatest common factors. They become a binomial together in the first parenthesis. And then the left behinds are the second set of binomials. And if you were to actually FOIL this, you would get that. All right.
Wait, so how do you know when you should do like a -7 or a positive?
All right, so if you were just doing this and looked at negative 21m plus 14 and said they share a 7, and we removed a 7, you would get negative 3m plus 2. And that is the exact opposite from what we need. And so since you removed a positive 7,
Okay, I
then
understand.
make it a negative 7 and it'll make it change its stuff up. You're just -1. All right, good with that? Okie doke. Next page. All right, I'm going to erase. I saw a lot of like, what in the world for number
I
18.
just remember there was like those 2 formulas for like the A and the B.
Yeah.
I just don't remember what they were.
So I got kind of tickled, so I thought, we'll just work 18 together. Oh, and let me say something about the exam, super quick. Like I said, it's 15 problems. You will have an answer sheet, a page where you list all of your answers. You will have a problem where you're going to graph. I know. So on the test, I did not put the graph. I did that on purpose. It's on the answer sheet.
On the exam?
Yes, it's going to make you go to the answer sheet to put your answers. And I have listed axis of symmetry, vertex. I've got it all listed out so that you don't skip any of the items in the directions. So the directions will read like that, but then on the answer sheet, it's like this and this and this and this. So there'll be nothing left behind. All right, axis of symmetry, AOS, that's what?
Opposite B over 2A.
Yay, you're gonna use opposite B over 2A. Oh, let's back up a second. When we say opposite B, when we're talking about A, B, and C, where do we find that? What is it referencing?
Standard.
It is the part, yes, it needs to be in standard form, but you're talking about the coefficients. And in this case, the 2, the 8, and the 5. So the A, the B, and the C. So we would have -8 over 4, and that means our AOS is going to be -2. So that's X equals -2. So then how do we come up with what the Y is?
Plug it back in.
We plug it back in. So we're going to square -2, which is 4, and then 4 times 2 is 8. So then plus, or minus 16 plus 5. And do you know what we get when we do that? -3. So Y equals -3. Now, that's an ordered pair. -2, -3. Here's your Y. That's what you're trying to solve when you plug in your AOS. So then you graph at -2, -3. Now this is where we remember the 1, 3, 5 method. Over 1, up 1, over 1, up 3, over 1, up 5.
6, 10.
So we're going to do 2, 6, 10. Why?
It's 2x.
Because of the 2. And is it going to be a happy face or a frowny face?
Happy.
Why?
It's possible.
Because it's positive.
Can you go over when you do the other one?
If it's negative, if the lead coefficient is negative, you would make it go over 1, down 1.
No, not the like 2, 4, 6. Like, what's the other one you can do?
1, 3, 5?
Yeah. How do you know when to do that?
When the lead coefficient's 1, or just like x squared, or negative x squared, you use 1, 3, 5.
And then if it's-
Anything else, you multiply the lead coefficient by 1, and then by 3, and then by 5. So if it were 1/2 x squared, you would still multiply, making it less than 1, 3, 5. So over 1 up 2, over 1 up 6, and then it's a mirror. Place these, and then you do a pretty drawing. Except mine's not very pretty. All right. This is called your what? What is the lowest dot here?
It's your starting point.
It is. It's your vertex. So when it says, is the vertex a minimum or a maximum value? It's your lowest point in this problem, so it's your minimum value. Domain and range. What is domain referencing?
X.
X. And what is it for this? What do we call, what's,
All real numbers.
all real numbers would be the domain for every
Wait, is it
problem.
minimum or maximum?
Oh, thank you. I said minimum and circled maximum. It's minimum. Thank you. All right, range. Range references what? The X or Y?
Range is the Y.
Range is the Y. And it's our lowest points. What comes above that?
Positive.
Positive infinity. So we would have a bracket, -3, positive infinity, parenthesis.
Do you always do your number first? then-
No, you do whatever comes first. So if we had a drawing like this, and here is our axis, our vertex, what comes first would be the negative infinity.
Start at the bottom and then go up.
Always start at the bottom and go up. So in this case, we started at the bottom where the vertex was. Here, it would be starting at the bottom where the negative infinity is.
Okay.
And go, and it still might be negative. It still might be a negative range. So but you start at the negative infinity and go up to the vertex. All right, then you've got the equation, and I need to rewrite that. I can't stand that I misspelled it. Vertex form. Who can tell me about vertex form? Y equals A, which is your lead coefficient, x opposite h squared, how does it end?
Plus K.
Plus k. And your ordered pair for your vertex, instead of xy, it's opposite it's hk. So, lead coefficient A, in this equation, we'll have a 2. And then x opposite h means plus 2 squared. And then minus 3.
Wait.
What?
Oh, wait, never mind.
Can you explain the minimum again?
Yes. So is vertex. So once you've graphed, look at the vertex, which is that point. And remember, the vertex is, the definition is your highest or lowest ordered pair, depending on the drawing, depending on the graphing of it. And in this case, it's the lowest number on the graph.
So -3.
So it means the vertex is the minimum value.
Okay.
But the vertex would be -2, -3,
Okay.
ordered pair. But like if we drew it this way, it would be the
Then
top
maximum.
point. It would be maximum. So frowny face gives you a maximum vertex.
How'd you get -3 then?
You took the opposite b over 2a and plugged that in, so -8 over 4, and we ended up with -2. Take -2 and plug it back in everywhere there's an x.
Even if there's a number?
So when you square -2, it becomes a positive 4. And then you multiplied that by 2 and got 8. But then minus 16 plus 5, and that's going to give you -3. Now, I'm glad you brought that up, Hensley. Let's say you have negative x as and negative x squared as your lead coefficient, and you have -2 as x. You're going to square it, which gives you a positive 2. But then there's a negative in front of your x squared, which is really almost like -1. So when you square it, that negative in front is going to make it become a -4.
So anytime there's a negative in front of the x in the first number, you always just keep it there.
Yes, you square it, treat that negative like -1, and then, make the positive go away. Comes back a negative. All right. Then we had, the bottom problems. You had to solve 20 and 22. So here are your answers for those two. Please be careful with the directions on the exam. A lot of you are great, you factor beautifully, and then you get to this section and you still factor beautifully, but you're not taking it to the next step of solve. The x plus 7, making it equal -7, +5. Don't forget to solve. All right, questions on those two before we move to the next page?
That's it.
All right, you had solve each with the quadratic formula. Who remembers the quadratic formula?
A. That's not it.
Opposite b plus or minus.
B squared.
Uh-huh.
A times C. B squared
Minus 4ac all over 2a. Notice opposite b over 2a is still traveling along with us, the axis of symmetry.
I felt like this was before Christmas. Trust me, friend.
It was not. It was after Christmas.
It's this term.
And then plus or minus, and then this. All right, so that's what you would do here. You would need to put those in standard form, which they are. I want to talk about the rocket ship. It's so fun. Making sure you're good with what we do here.
Well, the exam, are we gonna have to, like, whenever we get, if we get our answer as a square, are we gonna break it down into a number? Like plug it into our calculator?
Yeah, since you have a calculator, yes. All right, so we are looking at this rocket. It is obviously going to have a negative lead coefficient because we have gravity on Earth, which means it's going to go up, but it's going to come back down, and we're going to have a frowny face. as our parabola. So, first thing you always look for is what? To see if they have common factors. All right, and we can factor that, but let's look at the three problems that it's asking us about. Hitting the ground.
And running.
Yes. Where is when you're graphing, where do we consider the ground?
0.
0. So you're really looking for x. That's the x-axis. So for ground, that means you're factoring and solving. So you'll get your binomials and then you solve. Now, always remember when we're working word problems in measurement, it's going to be the positive answer. So you'll probably get a positive and a negative, and you just select the positive answer. All right.
So we set it to 0 and then use quadratic formulas to do it?
You
Or
could
just
do
add it?
quadratic, or you could just factor it. Because we're going to remove the greatest common factor, and then it's easy to factor. Maximum height, look at B and C. Maximum height, maximum and minimum height. What does that make you think of, I hope? Vertex. All right, let's look at that super quick. Vertex is X and Y. When you are graphing an ordered pair, your X is always time. Always time. And then your Y is whatever else is going on.
I got it.
Okay. So your X, look at this. How long did it take it to reach maximum height? Any ordered pair is a relation. So if however long X took, that's how high it's going to get, would be your Y. So really, when you're looking for maximum height and how long it took, all you're doing is finding the vertex. X value for the length it took, Y value for how long it took. Does that make sort of sense? Remembering? And then this is solving. What's the greatest common factor?
16.
Yep, and pull out a negative 16. So you would have negative 16 removed, because we need a lead coefficient to be positive. So t squared minus 4t minus 12. So two factors that equal 12, that when we subtract, we get 4.
6 and 2.
6 and 2. So we would have x minus 6, x plus 2. And your x minus 6 gives us a 6 and a negative 2. So the one you will use would be the 6. So 6 seconds before it hits the ground. And then vertex. I'll let you go from there. Look at the next page. Radicals, absolute value. This is rather recent. Radical means you're looking for perfect squares, removing everything perfect. So 32 can be broken down into what two factors?
16 and 2.
16 and 2. And if you had gone with 8 and 4, then you would still be breaking down further. 16 breaks down into what? 4. And then you have a 2 left behind. The b doesn't carry an exponent, so it has to stay under the radical. So 4 radical 2b. Absolute value references having under the radical exponents that are even, but when it comes out, it's an odd. So like b squared is under the radical would be positive. Would be even, but when it comes out, it would be a plain b, so it goes in the absolute value bars. You will have only a handful, like 2 or 3 on the exam, where you're going to have to remember to do absolute value bars, and it tells you in the directions.
What about b to the third?
B to the third. All right, so let's look at that. We'll do z to the third here. That breaks down into z squared times z. because you add your
You
exponents.
keep a Z out and then a Z in.
Yes, but the Z out's coming out at, whoops, as absolute value. As a Z. And then you'll leave one underneath. All right, moving down to the radicals when we are combining.
Dr. Everett, I can get some water real quick.
When we're multiplying, you can multiply radical by radical and non-radical by non-radical, but you can't multiply a radical and a non-radical. They just come and sit side by side. When you're adding or subtracting radicals, treat them like variables. Add only the outside numbers that have like radicals. So 40, we're going to distribute the radical 10 across the binomial. So when you do that, the 5 is not inside a radical, so it's just 5 radical 10. Then remember, radical multiplied by itself, like it is 10. Radical 3 times radical 3 is radical 9, which is 3. So when you're multiplying, you would just say plus 10.
Rock has a question.
Okay.
Rock.
Tell him to move on, and I'll come in a minute. I've got to
She
finish
said
this.
move on, so we got here in a minute.
All right, thank you. So from there, notice here, you're gonna need to FOIL, okay? This would be a perfect example of combining like terms. So you would have your radical 6's combined, and that's gonna give you 5 radical 6 minus 3 radical 2. And that's as far as we can go. 48, the 45 you can break down. Always make sure your radicals are broken all the way down. It has a 9, so we would have a 3 removing. So you would have negative 3 radical 5 plus 2 radical 5, and now our radicals are the same. So negative 1 radical 5.
Wait, can you go back?
Sure.
Are we gonna have time for the problematic? Only loaded, don't
Is
worry.
tomorrow our last class?
Mm-hmm.
Dr. Graham?
Yes.
I gotta get my computer charger. My mom just dropped it off.
Where is it?
She's like up there.
I mean, it's not in the high school. Sure. All right. Can I move on, Hensley?
Oh, yes, ma'am.
Okay. All right, then. Remember, the whole purpose, when you have fractions, it's always division. That's what it's referencing. The whole premise of this is you're trying to make the radical not be in the denom. You can have radicals all day in the numerator, but never in the denominator. So, let's look at 56. Radical 12, is it broken down?
Times by 2, right?
Do what?
2 times by 2.
No,
So I
No,
think it's in a
covered,
radical.
covered, yeah.
no, not yet.
Never mind.
So we've got to break down, look and see, 12, radical 12 is not broken all the way down. 4 times 3. So the 4 comes out as a 2. So we would have, this is 4 radical 3. No, I'm sorry, it is not. It is 2 radical 3. The 4 came out. 2 radical 3. So you're going to multiply the numerator and the denominator by radical 3. But not by the 2. You just leave it there. So radical 3 times radical 3 is radical 9, which is 3. And 3 times 2 is 6. So your denom is 6. Then you're going to distribute the radical 3, and that gives us radical 15 plus radical 6. And you're done. All right, 58 is different. It's addition. So you're going to multiply by its opposite operation, called the conjugate. So instead of 4 plus 2 radical 5, we multiply by 4 minus 2 radical 5. And when you do that, you're going to FOIL, and that will provide your outer and inner becoming 0. They will cancel each other out. And then you multiply the numerator by it as well. So 4 times 4, that gives us 16. And then when you do your outer and inner, it's a positive 8 radical 5 and a negative 8 radical 5, so that's 0. Then when you do last, that's negative 4 times 5, which is negative 20. So 16 minus 20 gives us negative 4. Then when you distribute the 3, you're going to have 12 minus 6 radical 5. What comments on our answer?
You can simplify the outside.
The outside, and it has to be all 3.
Negative 4 and 12.
And so we're going to remove, and the 6. They all
I
share,
think that was a B.
oh, it's a 6. They all share a 2. But we're going to remove a negative 2 because why?
We want it to be positive.
We want that denom to be positive. So we're going to do negative 2. So that means negative 6 plus 3 radical 5 all over 2. All right. Questions? All right, so I'm going to stop the recording.